Hi everyone, welcome to this class. Today we are looking at full wave bridge rectifier circuit. Remember we said in our previous video we've got two types of full wave rectification. The first one was center tapped transformer. So now the second one is going to be the full wave bridge rectifier. So what is a full wave bridge rectifier? The first point somebody has to note is in a full wave it means we are taking both positive and negative cycles. So what we will do, we will begin from the transformer. That is the first stage. You take the transformer like this, pick up the transformer, once you are there, you can now be able to draw the bridge rectifier. Remember, bridge rectifier has got 4 diodes. So the first diode, what you will do, you will have to draw it like this. Make it like a smaller triangle, and I hope you can divide it into 2. Draw the upper triangle like this. You can also make another triangle there like that. Then down here, you can also make another triangle like that. Another sort of triangle. Once you are there, you can now create some space where you can draw the diodes. The first thing you need to know is this first diode will be facing in that direction, like that. This other one will be facing in this direction. Remember, the first two, this one and this one, will be facing upwards like that. And then these other two will be facing downwards. I think later on we will be simplifying this diagram so that people will be able to understand basically what we mean. So you can see we have drawn, this one is facing up, this one is facing down, down and up. So once you are done with that one, you can now be able to draw this. You connect these at this point and you connect that. You don't have to draw this. Remember, basically when you are drawing a bridge rectifier, you can decide to draw your load here. This one can be your load, like that. But in most books you will find they have drawn it in this manner. They will decide to extend these wires so that now it appears down here. And you will see it is still the same thing. So what happens is you can extend this line. You can extend this line such that now you have your load on the other side. So basically you can see there is no difference between placing the load in between this and just putting it out there. So it is still one and the same thing. So this one now becomes our load. This is our load. So let us say this is our D1, this is our D2, this is our diode 3, and this is our D4. Whenever you are doing the analysis, you want to explain the operation. So basically, when we talk about construction, I've said the diode will require a transformer and it will require 4 diodes, and of course you need a load. When you talk about the operation, we will begin from the positive cycle. What happens during the positive cycle? And remember, it is good for you to number these things. You can say, let us say this is our A and this is our point B. We can also say, let us have these points. Let us say this is our point M, this is our point N. We can also say this is our point P, this is our point Q. If you also like, you can say we are having point X and the point Y. These are just arbitrary letters we are using for us to be able to identify the direction of the current. So very fast, the first thing you need to write, you need to tell us the status of the secondary output, the polarities of the output voltages at the secondary. So we know during the positive cycle, point A is positive, while point B is negative. That is the first point that you need to give us. You need to state the point A is positive while point B is negative. The second point, you will mention the polarities of the diodes, sorry, the status of the diodes. So we will say that during the positive cycle, you can see current comes from this point. The current begins here. We can say the current starts here, it goes this direction. Remember, this current will not be able to flow through diode 4 because diode 4 is reverse biased. We say the diode only conducts from P to N. It only conducts in one direction. So this current will follow this path like that. Reaching this point, it cannot be able to flow. Remember, the current enters this point and leaves from this point. So it cannot be able to flow from this point to the other point. So it now diverts to the load like that. It moves downwards through the load. It follows this path like that. It moves up. Remember, the current will not return to where it came from. If it has started from point A, it has to end at point B to complete the circuit. So at this particular point, as much as it can be able to flow through this diode, but what we say is it cannot be able to return to where it came from. So it has to pass through this other diode. It passes through this other diode like that. It comes down, then it comes through this point and goes to point B. So you can see during the positive cycle, diode D1, and you can see diode D1 and D3 are conducting during the positive cycle. These are the diodes which are conducting current. So we can say D1 and D3 are forward biased, hence conduct current in the direction. They conduct current in the direction. The current begins at point A. It moves to point M. From point M it goes to point Q. It goes to point X. From X it goes to point Y. From point Y it goes to point P. And then from point B it goes to point N. And then after point N, it now moves back to point B. That is the direction of flow of current. We can also say another point, diodes D2 and D4 are reverse biased. Hence, they don't conduct current. So that is basically what happens during the positive cycle. That is what happens during the positive cycle. We can now briefly look at what happens during the negative cycle. Then look at what happens during the negative cycle. Okay, negative cycle. Negative cycle. During the negative cycle, what is going to happen is this. We will have to put the status point. Point A is negative, while point B is positive. The next point, let us see how the current is flowing. If point B is positive, Then current, we know current begins from a positive terminal, ends at a negative. So our current will start from this point. So the current will flow in this direction. But once it reaches this point, remember it cannot be able to flow through D2 because D3 because D3 is reverse biased. So it moves up like that. Once it reaches here, it cannot be able to flow through D1. So it follows this path, comes down through the load. Then once it is there, it comes this direction like that. It comes this direction like that. It moves up. But remember, because it has started at point B, it has to finish at point A. So we just have to move up like that. D4 and so you can see during the negative cycle, the diodes which are conducting, the current is passing through this diode, comes down, uses D4. So during the negative cycle, D2 and D4 are conducting. So we say D2 and D4 are forward biased, hence they conduct current in the direction. They conduct current in the direction. What is the direction? It begins at point B. It goes to point N. Once it reaches point N, it moves up to Q. It goes to Q. After going through Q, it cannot move up. It goes to X. From X, it moves through the load to point Y. After moving from Y, we come up like this. We move up to point P. After point P, we go to M. And finally, we go to A. You can see, if you have started at point B, you have to finish at point A. But if you start at point A, you have automatically to finish at point B. So basically, that is the operation. And one thing that you need to note, that during both cycles, current flows. During both cycles, current flows through the load in the same direction. Through the load in the same direction, i.e. from X to Y. So you can see in both cycles, the current is flowing from X to Y, meaning the load will be experiencing a unidirectional current. So we want to look at the waveforms of this particular, as we finish up, we want to look at the waveforms such that now our input signal is sinusoidal, meaning it is a wave that takes this shape. That is our input. And because we have said during the positive cycle, two diodes are conducting like this, like that. So we can say during the positive cycle, D1 and D3 are conducting. So we can say during the positive cycle, it is only these two diodes which are conducting. During the negative cycle, remember we have said two diodes also conduct. During the negative cycle, we having two diodes which are conducting. So we talk about D2 and D4 are conducting. So you draw that and you draw these. So eventually, you can now talk about total waveform. Total waveform will be of this kind, like this. Then we talk about this, talk about that, like that. So that is the total waveform. So I want to wish you all the best. Thank you so much as we finish up this class. So that is it.